What if I have more than one predictor? What if I have more than one predictor? Specifically, what if I have both advising, whether you got advising or not, and whether you went to a public or private high school? So I might have a model like this. The mean of y given whether you had advising and given whether you went to a private school for high school, perhaps looks like this. Beta 1 times advising plus beta 2 times private, where this is a 0, 1 variable and this is a 0, 1 variable. The difference between this example and the previous example where there's 3 advising groups is now it's possible that you got the advising and you went to a private school. These could both be equal to 1 now. So the possible values you could have here, you could come in and tell me you have someone who did not get advising and did not go to private school. So I could be trying to calculate the mean of y given that advising is equal to 0 and private school is equal to 0. Or you could tell me you're interested in the mean of y where advising is equal to 0 and private school is equal to 1. Or you could tell me you're interested in the mean of y where advising is equal to 1 and private school is equal to 0. Or maybe the mean, I should say the mean of y where advising is equal to 1 and private school is equal to 1. So if I use this equation that I have here to calculate each of these quantities, I've got beta 0 plus beta 1 times 0 plus beta 2 times 0. That's just the beta 0. Here, I've got beta 0 plus beta 1 times 0 plus beta 2 times 1. So there I've got beta 2. Here I've got beta 0 plus beta 1 times 1 plus beta 2 times 0. And here I've got beta 0 plus beta 1 times 1 plus beta 2 times 0. Okay? Really, by having these two dummy variables, these two indicator variables, these two 0, 1 variables, my data is being divided into 4 groups. I have the 0, 0 group, the 0, 1 group, the 1, 0 group, and the 1, 1 group, and perhaps there are some data points in each of these, and they each have a mean that I could calculate. And so following the format we've been using in other circumstances, this is the beta 0. That's going to be my estimate of beta 0, the mean in the 0, 0 group. And beta 2 is going to be the difference between that baseline and the mean in the 0, 1 group. And beta 1 is going to be the difference between that baseline and the mean in the 1, 0 group. The way I've written this equation, the mean in the 1, 1 group has now got to be beta 0 plus beta 1 plus beta 2. It's got to be up there, right? Beta 2 and beta 1 are both positive. Here's the baseline of beta 0. According to this model, the mean's got to be up there. So this model actually isn't enough. This model isn't appropriate if I drew the data this way. This model assumes that given that you don't have private school, let me say it differently. This model assumes that given that you don't have advising, the impact of private school is equal to beta 2. And given that you do have advising, the impact of private school should be the same number. That's not what the data says, but that's what the model says. This model says that given that you went to private school, the increase that goes with advising should be the same whether or not you went to private school. That's what this model says. And it's not appropriate for the data set that I drew there because the mean of these data points is down here. It's not up there. How would I fix that? I could fix that using an interaction, which just means I add one more term to this model that comes from multiplying these two values together. If you didn't have advising and you didn't have private school, then this is just 0 times 0, and this number won't change. If you didn't have advising, then there's a 0 in this last term, and this number doesn't change. If you didn't have private school, there's a 0 here. This number doesn't change. Only down here, when you do have advising, you do have private school, do we need to add a beta 3. And what's the impact of that? Now beta 3 is equal to the amount by which the mean in this 1-1 group differs from what we would have gotten if we hadn't put that third term into the model. Why do we do that? By putting in this interaction, we're allowing the 4 groups each to have totally different means. If we didn't put in that interaction term, then we're insisting that, again, the increase in mean GPA when you have private school versus not is the same regardless of whether you have advising, and that the increase in mean GPA when you have advising is the same regardless of whether you went to private school or not. If you put in the interaction term, that's no longer the case, and now you could estimate each of these 4 means separately.